Hey everybody, Lars here. Time for the second video that we're going to do for Unit 5. In Unit 5 I usually do 3 videos. I'm going to do 3 videos. I can't remember whether I did a 4th for something else that I wanted to show you. We will find out, time will tell. But as far as your slides are concerned, they break down into 3 distinct areas, and we're going to do a video for each of those 3 distinct areas. So we're going to review a little at the beginning of this one because, you know, object-oriented programming in classes, it's a little different than what you've been doing. So I want to get it through, and what I've always done and what I always say is that I always think the best way to learn about classes and the best way to learn about object orientation at first is to see a lot of examples. So you got the dice in your slides, and then you got that student record, and then the first video you did a bank account. Today we're going to do something different. I whipped up an animal class, and I want to show you, first we're going to do something with this animal class, and we'll trace through the code so we get back in the habit of knowing what we're doing when we use object orientation. And after that, we're going to create a new class called cat, and we're going to use something called inheritance. And I'm going to show you that it's a very good way to save yourself a lot of time. I did not grace the university with my presence today because I had to be home because the Geek Squad kids came and swapped out my 60-inch TV, which stopped working a couple weeks ago. And they did, they fixed it. It's up on that wall, and I hooked up the PS4 to it, and I'm looking at Diablo Eternal Edition. Eternal Edition, not internal. So I'm a pretty happy camper right now. But I didn't get to it last night. Last night ran a little later than I wanted. So I figured I better get on the stick and get you this Python video because, like I've said before, I want to front load all these resources. Because if I front load all these resources, then you can get going on your project earlier. Not your project, your homework assignment. And that's a good deal because this one, you're going to see, this one's a little weird and you're going to have to think out of the box. And you're going to enjoy it though. You'll have fun. All right, I'm going to create a variable. I'm just going to call it my animal. And I'm going to assign it an object I create with the class animal. And I am going to give the animal the name Fred and 30 because this particular class, and we're going to see it when we go over it, takes a name and a weight. So I'm going to do that, and then I'm going to print my animal dot get name. All right, so let's run this code. And there we go. Good old Fred's name is up there. Now let's get an area we could work with where we could see all the code we're working with. And that will probably do. You're going to see by the end of this video that we've finally gotten to the point where you're not going to be able to keep all the code on the screen. We're finally complex enough that we're going off the screen, people. So you've learned a lot. You've done a lot. You're going to see how that goes later. All right. First off, a real quick trace. You've heard it before. At the beginning of the program, it's a comment, so Python ignores it. A class, like a function, it's a definition. It's not really being used at the time. So Python puts it in memory to be used later. So all of this gets put into memory. Another comment, literally the first thing we run is the second to last line of the code. And you can see we create a variable called myAnimal, and we assign it an object that we create with the class animal, and that we give the instance variables of Fred and 30. So what happens? The animal class gets called. And what happens when you create an object? You run the constructor. So we run init with self, which is, as we know from the last video, kind of a memory location that points towards the actual object that's been created. And name, which in this case is a string called Fred. And weight, which in this case is an integer, 30. Okay? And we set these 2 instance variables. In the constructor, that's where you're going to set your instance variables up. And these are variables that are specific to that one object. You can create another animal and give it different instance variables. But right now, this one object is the one that we're working with. Okay, you could see I have getters and setters for both name and weight variable. Okay, in past videos I go into it. I don't think I'm going to do it as much in this one, but basically you might be saying, hey, if I can just access the variable from using the object, why do I need these getters and setters? And it has to do with when you first learn about object orientation, the first thing classically that people learn about is this thing called encapsulation. And what that is you can make your class public, you can make it private, you can make it protected. If you're a Java or a C++ person, you know what I'm talking about. I don't mess with that stuff at all because you know what? A lot of programmers don't mess with that stuff at all. I make everything public. okay? But I do want you to know about getters and setters, and as a habit, I always do getters and setters, okay? The whole thing is that if you inherit from a library, sometimes the programmer doesn't want you to see all the code, and he can give you private access so that you can use the code, but you can't really change it, and it gets into the weeds. And because, and I've always said this throughout, I got to pick my spots. I got 15 weeks, less in your case, 11 weeks, to teach you Python. So there are certain things that just aren't important, and you can learn it quickly when you hit that in your careers. And encapsulation is one of those things. Just don't worry about it. You'll get to it when you get to it. That's why I do inheritance and polymorphism, because those are the two important things that I want people to see. All right, enough said. So now we have our getters and our setters, and then I have one method down here called speak. And you'll see it's kind of weird because it says print sound, but you're going to understand it later, because the reason it's there is so we can talk about polymorphism, okay? So I do that constructor, and then I print myAnimal.getName. What's myAnimal? It's a variable that holds an animal object, an object that was created with class animal. So I come up here to class animal, and I say, do I have a method called getName? I do. What does it return? It returns the instance variable self.name, which, with the constructor in the first line, we gave the string Fred. So we return Fred to the calling method, and we print it, and that's why we get the Fred right up there. Okay? So that's object orientation. You create that class, you create that blueprint, and you get an actual object, and then you play around with that object. You can run all the methods that you built for it. You can use the data that you have with it. At the end of the day, like we do in your slides, you got two things. You got attributes and you've got behaviors. And that's kind of what the data and the slides are, okay? The slides, the methods. So now, on to inheritance. I had decided I don't just want an animal class. As a matter of fact, I'm going to zotz all that out. I want a class for a cat. Okay, I want a specific animal, and I'm going to call it a cat. And you might ask, okay, do you now have to create a class for cat? And the answer is yes. You have to create a class for cat. But we're going to do something so that we don't have to do all of the other work that we already did in animal. I'm going to type class, and I'm going to say cat. And one of the things you may have noticed from the first video is I had checking and then colon, and now I have these two parentheses there. It doesn't matter. Either way, Python is fine with it when you're doing classes, okay? The reason those parens are there is because that's what you use when you inherit. So in parentheses, after I say cat, I'm going to say animal, and then I'm going to define my class. But, you know, you have to pay the ferryman, and I'm going to show you what we have to do in order to do that. So the first thing we're going to do is we're going to do our init. So we do an init, and what are we going to ask for? Same thing we did up there, self, name, weight, only this time I'm going to add color. Okay, and we're going to know what color our cat is. All right, now I hit that. This is where we have to pay the piper. What cat's really going to do is go up and grab an animal object and use it. So what we need to do right now is not really declare a variable, but call the constructor of animal. So what we do is we tell Python, hey, go to animal and run the constructor. Okay? Now, in this case, we're going to say self, because we want to tell animal we're coming from a cat class. Okay? And then we're going to give it name, and we're going to give it weight. Okay? Boom. That's it. Okay? Because color, you know, animal, look up here. Animal doesn't know anything about color. We're only going to use the previous class for name and weight. Now for color, we're going to treat it like we would a regular instance variable because it's new. Right? Boom. Okay? Real quick. Return self.color def set color. I don't know how, unless we're bleaching the cat, I don't know how we're going to do that, but then you would accept a color, and then self.color would be assigned the new color. Just that fast, you've got getters and setters, okay? You only need it for your new variables because the getters and setters for the other things have already been written, and we're going to use them when we inherit. And you're going to see when we trace through this code. Now, I'm going to do one last thing, and we're going to use it when we deal with polymorphism. I'm going to print meow, because I know I got a cat, right? Why is that not? Is that why? Yes. All right. Excellent. So now I'm going to test it. As you can see, we're off the screen, but that's okay. So now I'm going to test it. I'm going to grab a variable. I'm going to call it cat1, and I'm going to assign it the result of a cat call, and I'm going to call my cat Felix, and I'm going to make Felix 50 pounds. Felix is a fat cat, and Felix is going to be, I'm going to make mine orange, although I think Felix the cat is black or brown. Okay. So now what am I going to do? I'm going to say print cat1 dot get name, cat1 dot get color. All right, when I run this code, what is going to happen? Felix, okay, something messed up. Did I not name it that? Color, something color equals color. What did I do? I did cat1. Get got to tell it I'm running a method and not give it the pointer. There we go. You could never mind that. Never mind the man behind the curtain. we asked it to print the method handle and not actually run the method itself. You need the parens at the end in order to run the method. Long story. As you can see over here, we got Felix and orange the last time we ran it. So that's what we're going to go with. So let's trace this and see exactly what happened here. This, if you're just getting here, really quick, you must think this screen looks crazy. Cat1 is a variable. It was assigned an object we created with the cat class. So do I have a cat class? I do. It's right up there. We're going to give the cat class Felix, the integer 50, and orange. Okay? So I come up here to cat. And I got self, which is, pointing to the actual object itself. I got name is going to be Felix, weight is going to be 50, and color is going to be orange. So what do? I call the constructor of the class I inherited from. So I'm going to come up here, and I'm going to give it Felix, and I'm going to give it 50. So self.name is going to get Felix. Self.weight is going to get 50. And I create a little animal object that I'm going to use with my cat. Okay, and then color, which was orange, just gets set to its own instance variable in cat. So animal doesn't know a thing about color. All right, that's all when it comes to the cat thing. All right, so I do that, and then it comes back to the second line because now I have that object. I print cat1.getName. Okay, so what's cat1? It's a variable that points to an object that was created with the cat class. I go to the cat class. Do I have a getName? I got a init, I get color, second, the answer is no. So right now, Python wants to throw an error. But Python says one thing, did I inherit from a class? It comes back up here and says, yes, I inherited from animal. So what it does is it goes up here to animal and says, do I have a method called getName? Init, getName. GetName is there. Because we ran the constructor before, self.name has Felix in it. So we return self.name, and it gets done right here. So that's why we get the Felix right there, okay? The second part of it, cat1, what's cat1? It's a variable that points to an object that was created with the cat class. So now we go to the cat class and we say, do we have a method called getColor? And then come down, and it turns out we do. So now we don't have to jump up to the animal, okay? Because we have it right here in our regular class. So then what does it do? Return self.color. When we ran our constructor, that got assigned orange, so we return orange. Okay? So you're probably saying to yourself, yeah, okay, big deal. But you've got to keep in mind that a lot of classes that are out there will have constructors that are 30 lines long, and they will have 50 methods. Okay? And sometimes it's great because you want that functionality and you just want to add a couple things to it. Well, that's what you can see how much shorter cat is, and how cat basically just takes care of color and we take care of everything else. with animal, okay? Think of, and in programming, we usually call them base classes. There are some big classes out there that are never meant to be instantiated. They're meant to be inherited, okay? Because they give you a lot of base functionality. Let's say you wanted to make a car, okay? Cars have 4 wheels. Cars have axles. Cars have steering wheels, okay? There's certain things that are in common with all cars. So we can write that functionality in a base class called car. And then what am I going to do? Am I going to instantiate that car or get like some platonic type? No. I'm going to inherit car when I make my Lamborghini, when I make my Volkswagen, when I make my Jeep, okay? I'm going to use the base functionality of that already written class that has a ton of things in it with a ton of methods already written. Start the car, stop the car, put the car in gear, all of that stuff. All the things you would do with that actual object. And I'm just going to inherit it all. And then I'm going to add the niceties that make my object particular to that base object. So that's what this is all about. It's about taking big functionality and just adding a little bit to it and specializing it and customizing it for your needs. Okay? Because when we come back for our third set with this video, we're going to do a dog. And we're going to do a whole bunch of different things that I'll show you. Like the third video is, first one was classes and OOP, big topics. This one's inheritance, polymorphism, big topics. The next one is going to be, let's pick up some fun stuff. So we're going to talk about like 5 different things. But it's cool, and you're going to see how we could do a lot of different things with classes. Right now, the last thing I want to do is I want to discuss polymorphism. So, leave that there. Now, you know what I'll do? I'll doink this. And I'm just going to say cat1.speak. And because it prints, I don't need to assign it to a variable. I don't need to treat it like a fruitful function and capture the value for later, either with a print or by assigning it to a variable. I'm just going to have the cat speak. So when I run that code, I get meow. Okay? Now, let's trace that. I'm going to trace all the earlier stuff. Cat1 is what? It is a variable that holds an object created with the cat class. I go to the cat class and see if I have a method called speak. Boom, 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 I do. So what does speak do? Speak prints meow, we get meow, okay? But let's think for a second, what would happen if we didn't have? What do we do? It says sound. So what happened here? Cat1, variable, points to an object that was created with the cat class. Does it have a speak method? I go up to cat, init, get color. This time it doesn't because that's commented out. So we go up to cat. Did you inherit from anybody? It says yes, I inherited from animal. We go to animal. Does it have a speak method? If you come all the way down here, you get to speak and it prints sound, and that's why we get the sound there. Now you might be saying to yourself, all right, that's kind of like inheritance. You know, why is this anything different? Another thing too, if we don't want to print anything or we don't want to do anything, we can just use the keyword pass, which is, you could see idle made it orange, and that just means do nothing. So now if we reran it, it would just do nothing. See, if Python, if you declare a function and then you leave it blank, Python says, no. Python does not like that at all. That's another thing. Sometimes Python will throw the error after you've left. You have to have something, and that's why you have the pass keyword. So now if you put the pass keyword there, you run. Nothing happens because we called speak and it went down to here, okay? Usually when you see the pass command in a method like that, it's because you have something that's called an abstract class. It's not meant to be used, it's meant to be inherited. And in this case, because it's polymorphism, it's meant to be written over, because this is the story with polymorphism. What's the difference between this and inheritance? When we inherited all the animal stuff, we inherited get name, set name, get weight. The difference with this is it's the same name. It has the same name, speak. So what we're doing is we're fashioning the functionality of speak depending on its context. So if I've got a cat, I better have a speak that says meow. And if I have a dog, I better have a speak that says bark or woof. And if I have a cow, it says moo. A pig, it says oink or grunt. You know what I mean? So polymorphism, if you break down the word, poly is what? Many. Morph, I think, is the old Greek, which means form. So it's many forms. And that's kind of what we're going for when we do polymorphism. If you do something like I'm doing here, which is, I guess you would call the zoo example, I do a base animal, and then we get cats and dogs and pigs and cows. They're all going to have a method named speak. And speak is going to, depending on the context, and when I say that I mean, is it a cow? Is it a cat? Is it a dog? It's going to speak what it speaks. That's what polymorphism is about. So basically when I do animal and I have that speak method there and I do pass, it's basically telling the programmer, hey, you're going to inherit this. When you do, you better write a speak method. And you better write one that, you know, acts properly, which is why you might put print sound. You know what you would have? You'd have a comment there that would say, hey, when you write your class and you inherit from this, make sure to make the proper sound for the animal or something like that. Okay? So when we talk about polymorphism, we're talking about the same function but defined differently in all the different classes. So that way, if you think about it this way, let's say I create a class, cat, I could put it in a list. Dog, I put it in a list. Moo. Cow, it's going to say moo. I put it in a list. Then another cat, another dog, another list. Blah, blah. Then what if I want them all to speak? Okay? I don't have to go and give a different function name to every single object. I could just stick them in a loop and say run speak. Okay? So think about that. I would do for I in my list, and then I would be the name of the object. You just go I.speak. And for every one, woof, woof, meow, meow, moo, oink, down the line. Okay? That's what it's about. It's about them having the same name. Okay? And also, when you have a base class or something that you're pretty sure you're going to inherit from, because it's too generic, no one has a generic animal, okay? Then that's going to tell you, hey, I better write a speak method for my particular class that I'm going to do. Okay? All right. Then I'm going to leave it for now. I know tomorrow I'm going to do the third video, and after that I'm going to do a bunch of announcements. The only thing I'm going to say to you, because I haven't really spoken to it yet, is that I haven't forgotten about your midterms, and I haven't forgotten about your midterm grades. I'm going to get on that. Anybody who sent me email the last couple days knows that I'm on vacation next week, but that doesn't mean I'm on vacation from Python. I'm never on vacation for Python. There's no such thing. So we're going to be business as usual. So if you send me email and you get that kickback that says Lars has gone away until basically August, don't worry about it. All right? I'm still around. Send me email if you have to. And this weekend, early next week, I'm going to get to the grading of the midterms, and I'm going to get you those grades before the end of Unit 5. And Kit, over the weekend, is going to grade all the stuff from Unit 4. So we're going to get you up to date. We're going to get you your grades. You're going to know where you stand. You just worry about your proposals, which are going to be due Sunday. If I end up getting them by Monday, it's not going to be a problem. I'll probably put that in an announcement later. And Unit 5. Just steep in Unit 5. Do it the right way. Okay? If Unit 3 got away from you, now's the time to listen up and make sure Unit 5 doesn't get away from you. All right? Don't worry about all this code. I'm going to put all this up on the web, so you're going to have this. All right? At the end of video 3, you're going to have everything, because you're going to see tomorrow we're going to build on this, and we're going to add a dog, and we're going to do some other stuff. And then actually we're going to stick it all in a library, because a class is just like a function. So we're going to throw all our classes in a library, and we're going to do all this with like 2-3 lines in a main program. All right? All right. Then I'm going to get out of here. You be good, and I will see you later. Enjoy your weekend and do those proposals. I'm looking forward to seeing them. All right. Bye.